On this episode, we make a mess. In case you missed it, we got the wheels and the spindles and the axles all mounted to this frame. Now it's time to build the platen, which is the flat working surface that the work is gonna ride against. But we got raw stock we need to cut everything out of, so let's start that now. This is where all the magic's gonna be happening. This is the platen that we're gonna be pushing our material up against. This is a piece of Hardox 1/2-inch plate that's commonly used in earth moving equipment. It's really wear resistant. It's easily weldable. I'm gonna use it just for wear surface. But I want to manufacture here a vibration dampening platen, kind of like a dead blow hammer. I've fitted some ports on the top and bottom, and then we're gonna cap this. So there's a cavity inside here. So we'll be able to pour in some garnet or some sand, someplace to just keep some of the vibration out. I think I'm at that point where this is a cool experiment to see if this really works, which it should. So now we'll fixture it all up and we'll weld it together and we'll start assembling it on the main machine here. So let's get to it. We got the platen and the base all fabbed and welded to the main frame here, and everything's just turning out super precise. Man, this thing is fitting together like we're making a clock. Here we have slots behind this platen, and there'll be a long bolt that you can access from the other side. And these long bolts will be the clamping force, so I can clamp this platen to this base. I got quite a bit of adjustment, so I can adjust forward or backwards or whatever I want to do, okay? But in order to get that fine adjustment that I'm after, no Go Kart inspired belt grinder is complete without some Heim joints, right? So I keep these Heim joints in the shop all the time. They're super handy for a lot of stuff. If you've never seen these before, one's a left-hand thread, one's a right-hand thread, and you can put a rod or a tube steel between them. And I'm gonna put something in here on the bottom and on the top to where I can turn it by hand and really precision dial in the platen whenever I need to be adjusting it or calibrating it. So I think we should tackle that next, and we'll bring you back when that's all done and I'll show you how it works. Like that. So you can see my platen isn't adjusted right. You can see we can adjust it. You work so hard to get to a point to see something actually come to life. This is turning out better than I expected. Pretty cool. Let's do a little sound test because we haven't filled this platen yet with garnet or sand or water or whatever I end up putting in here, but you guys are probably curious like I am what it sounds like before, and we'll do an after test. I want to take this platen off, and I think I want to take it to the shaper, and I really want to dial this thing in flat and see how the shaper does cutting this hardened steel plate here. So let's take this thing apart and we'll bring it to the shaper. We're going to try this carbide tool. We are running 23 strokes per minute at a 25-inch stroke. We're only going to be taking like a 32nd to a 1/16 of an inch off the surface here. Let's stop the machine and see how the surface finish is looking. Look at that. What do you guys think? That looks pretty good. That insert's doing a fantastic job. Absolutely beautiful. Look at that. That almost looks like it's surface ground. Would you take a look at this? Man, this shaper did a fantastic job on this platen. It almost looks like it's ground. One of the reasons why I kind of like this grain that the surface, in the surface is it's really going to help the belt be frictionless as it goes by here. If we did this on the Kearney Trekker or the milling machine, we'd get these swirl patterns, which I think would add friction. So we have our little bosses welded on the back for our adjustments to be able to push this back and forth, our ears to be able to adjust it back and forth, and our plugs. And the plugs are on the top and the bottom, and I'm gonna fill this full of garnet that I use in the water jet. This is a number 80. We'll open this up and I'll show you what it looks like. But now's the time we're gonna fill this up to see if we can get rid of the resonance sometimes you get when you push against the platen. It almost kind of rings. So I'm gonna try to make this a dampening platen. We'll see if it works. So let's fill it up now. Okay, that should work. Somebody should have made the hole bigger. Okay, I think that's all she wrote. Hopefully this should sound kind of thuddy. Here's my hand. Sounds like meat slapping this thing. Feels pretty solid. Let's try this. I don't want to scratch my surface. But, ooh. Up here, obviously. Big difference here. Before, now. Before, now. Man, pretty good. Thump, thump, thump. Here's this one. I like it. I'm pushing hard against it. Man, this thing's so smooth. It's very impressive. I don't think the milling machine could do this nice of a job. I was actually pinching this belt. This is something we're grinding. We're pinching this belt in between this and the platen, so it's causing a lot of demand on the horsepower of the motor. Say I wanted to grind this little hooker or something, I can get around to the corner of the platen this way. And then too, I can get to my fasteners through here, but it just provides that extra clearance I needed to be able to roll around the side of the platen. So that's why this frame's cut out like this. Next time we build the working surface for the belt grinder. Please like, comment, subscribe, and I'll catch you on the next one.